Hello, hi. So today I have picked the one more interesting problem, which is a design LRU cache. So I will first walk you through the problem statement. Then I will tell you the intuitions and what are the algo data structure and will be the classes for these design. And then I will also provide the implementation of this entire implementation in Java. So let's jump into the problem statement first. Okay. So let me just okay. So problem statement is says like design in memory LRU cache. So you are building a cache library that will be used by multiple backend service. So and implement the in memory cache supporting the following requirements. First one requirement is the put, get, and cache has a fixed capacity of n. Okay. When the cache reaches the capacity, we need to evaluate least recently used one key. For successful get and put, we should mark the entry as a recent used one. Okay. So this is the functional requirement where I will need to do a series of operations. Okay. And expectation is for the performance of these three operations is constant, which is big O of 1. And non-functional requirement is cache should support the millions of operations, and memory overheads should be minimized, and design should be extensible for future eviction policies. So I will design a such way so that our main cache class should not tightly coupled with the eviction policy. Okay. So we will keep separate eviction policy class so that it should be extendable in future. So in future, if we will need LFU and least frequent used one, or FIFO, first in first out order for eviction policy, then we will able to do that. And the fourth point is API should be thread safe also. Okay, this mention is API should be means all these three operations should be thread safe in case of concurrency. Like if we have multiple thread access in same time, then it should be a thread safe operation. And phase 2 requirements is we need to add a TTL for a given key, and thread safety I have discussed. And fourth point is like we should also uh, calculate the matrix of the hit and miss and eviction count. Okay, so this is the statement. So let me jump into the design where I have note down the some major operations and how will we do. So for these three operations, get, put, remove, I will be needed these three operations in constant time, which is big O of 1, right? So think of data structure can be which will give this complexity. So one is the hash map, right? If you think hash map, we can get a value for a given key, and we can update or insert a value. We can remove all these three operations we can get in constant time on average. But along with access, or we need to we need to update ordering, right? We need to make sure of the ordering. We need access plus ordering also, right? So for a get a key, for a put a key, we need to move into least means most recent used position, right? So single data structure can't solve this problem, right? So we will need for if somehow we get a node, if we think of like a array, if we think of array, we will need to iterate the array, and this will give the big O of n time complexity, which is not constant. We can't use the array. So doubly linked is the desired one structure for this one, which will give the time complexity of these operation in constant time. If somehow we get that node, then we can do anything for that. Like we can delete, we can move to any particular position. So we need to keep maintain the we need to maintain the key and node mapping somewhere like in HashMap, so that we can get the node for a given key in constant time, so that we can perform the operation in doubly linked list. Okay, so for this we will use the HashMap also. Okay, so this all these three operation of the LRU cache will be solved like the two structure. One is I have to use the hash maps. Second one is the doubly linked list, which combinedly provide the constant time complexity. So eviction policy, as I told you, like can be anything, but in especially I will be designing the LRU, but it can be extensible to LFU and FIFO. So this eviction policy responsible for the ordering, right, of the key. How the ordering will be made, this is decided by the eviction policy algorithm. Okay, so this is where the keys matter, right? So for a given key, if we have a node, we can perform the any operation like delete and add into doubly linked list. Okay, and think of, as of now we have like discuss, we needed two classes. One is for eviction policy, and second is main class for the cache. So for a cache will tell you responsibility. I will tell you the class responsibility. Eviction policy will tell you the ordering responsibility for a given key, and cache will tell you the what is the value and the TTL for a given key. So wo, so single class should have only one responsibility if we follow the solid principle. So we'll take care of that. So before dive into that, let uh, think about the series of operation for each method we will be needed. Okay, for a get, if we for a get operation for a given key, first I will check the if it exists. We will need to check the TTL. If it expired, then we remove from the cache and eviction policy. If it exists, that return the value and move it need to move to most recent used position. Okay, in this case, TDL tail pointer, tail pointer I will keep as a most recent used position. Okay, and DLL head pointer will be pointed to the least recent used position, which we will evict in case of capacity size of the cache will reach to the capacity. Okay, for the put operation for a key, if it exists, just update the value and unlink means delete from the current position and move to the most recent user position. If not exist, then create a new entry, add to the cache map, and also add key to eviction policy. When it reaches the capacity, we will fetch the key to which need to evict from cache. This will tell by the eviction policy mechanism. Okay. For remove, we will need to remove from cache and eviction policy both. Okay. So for single unit operation, think of single unit operation. For these, if you see for these get, put, and remove, we need to touch two structure, right? One is hash map for access or update. For access or update, also we need to touch that doubly linked list. So we need to touch two data structures. For thread safety, I will use the ReentrantLock, global ReentrantLock, which will ensure this series of operation into single atomic operation. Okay, all get, put, remove operation I will treat as a single atomic operation. So I need to serialize it. Means, so I will need to like for a get operation. I in get, if you see, I will need to first fetch from the cache, main cache. Then we will need to update that key. Means move to most recent use position. We are modifying the doubly linked list, so we are touching to structure. So these two operation is single atomic operation. So all these two or three operation need to serialize. So we will put the global lock, unlock once all these three operation will completed. So if you ever thinking about the, like, we have already lock free mechanism for HashMap, which is the concurrent HashMap. So we can't utilize that, because we only utilize if we have only one, like if we have only cache map, we don't have the doubly linked list, then we, where the uh, cases concurrent hash map will be useful. In case of combining operation, that won't be useful. We only adding the extra overhead, right? So we, so for that we only use simple hash map. Means not thread safe. We will utilizing the global lock, which will ensure all these operation into uh, thread safety by making atomic operation. Okay. Second point is I wanted to discuss, like I want to discuss like cleanup. Suppose for a key which is like expired, we are adding TTL, right? So key can be expired. So there are two mechanism to clean up these expired keys from the cache. One is lazy cleanup, which I will prefer. I will prefer for this design. For design. Okay. Then background cleanup. What is background cleanup? We schedule the job or cron job, which will scan all the keys in the hash map, in the cache, like cache, and check the expiry time. If any keys expired, then it will delete from the cache and eviction policy. So the it make the memory available to the genuine one. Okay. Lazy cleanup is like cleaning the expired key on a fetching, on a accessing, on access. Okay. For matrix population, like for hit count, miss count, and evict count, we just need to uh, keep all three different variables that will keep the statics of these count. So let me define the classes diagram for this one. So first class is cache. I will make it generic. Okay, key and value. And what I will other needed, I will needed, let me just dog, let me just move it here. Okay, so this will be the, okay, for eviction policy. I will needed a contract, okay, interface, so that it will all other subsequent classes, any other eviction policy strategy will follow that the same, so that we can just replace that. Okay, so I will need an interface, make it, let name it eviction policy, which will depend on a key. So think of when the ordering can be changed, on access, on update, on remove, right? So on access for a key, void, on a insert means adding a new key, right? And void on a remove, we need to remove from the policy structure data. And fourth is the evict. It will tell us, it will tell the cache class which key need to evict from the cache, right? So this is all four contract will follow uh, by the further subsequent classes of the eviction policy study. Okay. What will be the eviction policy study? Let me just remove this one. I think let me delete it. I will just use this one already create a template. So let me just LRU eviction policy which will implements the eviction policy. Okay, implement the eviction policy. And uh, I will need a doubly linked list, right? As discussed, I need DLL. So doubly linked list, I will create on my own custom doubly linked list. So I will also need define a node which will have a like on a key. Okay, node head and tail, and just put it here so that it will looks better. Just white, put it here. Put it here. Okay, so this is head and tail, and I need to I also needed in constant time for a key. I need a node which need to move or move to tail or need to delete from current position. So I need in constant time, right? So I need to make mapping of key map key and this node so that I can get in constant time. Okay, so this will be implemented by this one, and okay, and this will be implemented used by this one. Okay, second one is the what the main cache class would have. It will have a cache map, okay, for a key and entry node which will have a value, and it will have a capacity, right? Initial capacity. Also it have a eviction policy, right? It will also have a locking mechanism, like ReentrantLock will have a lock. It will also what miscount, hit count, miscount, right? Miss, hit, and evict count. Okay, this is what this will have. Some inner class I will not mentioning here, like node I will define the inner class of this LRU because I am implementing custom like my own doubly linked list instead of utilizing the linked list structure provided by inbuilt in Java. So, and cache I will make an entry node for the storing the value and the other metadata like expiry time TTL. Okay, so this is the main things. So whenever we will be needed to switch to any other eviction policy, we just need to like define another like MFU uh, eviction class, LFU eviction class. Just implement all these contract according to that algorithm, and we can pass into that. Okay, so I think we have covered most of the things are related to the design. Let me just walk through again what are the left. um, Memory overhead. I have discussed the threat safety. I have discussed the TTL and matrix. Okay, I have discussed most of the things. I think here. Let me just. Okay, so let me just write. Uh, Let me just move to the its implementation. Okay, so just I hope my screen visual to you for implementation. Okay, so this is the implementation I have implemented. So I will walk you through the each code which I have discussed in the design part. So this is eviction policy I have discussed. This is the interface contract which will follow by other its subclasses like LFU, LFU or LRU or FIFO. So any future classes, eviction policy classes will implement these contract method, right? So that we can replace without touching the main cache class code. Okay. So on access. So I have define the LRU eviction policy class. So because we are designing the LRU case. Okay. So I have implemented the eviction policy. First, I will created the node static inner class node, which is static, so that it won't get a reference to the parent class to minimize the memory overhead. So I have defined the head and tail and map, which will maintain the node for a given key to get in constant time. Okay. On a defining the object of this one, I will just linking the head to the tail. And let me, this is the helper person, helper function uh, for a given node. If I need to unlink, means the delete from current position, so in doubly linked list just update the previous pointer to the current to the next pointer, right? So this is the simple just double linked list deletion implementation. Add to tail, for a given node we need to add into a tail for the given doubly linked list. So we are just updating the pointer. Okay, here. So I am overriding which contract method you need to implement according to the LRU. According to LRU, for a given key, first I will get a node. So that's why I am making the hash map for this one, so that I can get a node for a given key in constant time. So I will check first, if it null, just return nothing, do nothing. If not, means action. On access we need to unlink, we need to delete from current position and move to the most recent used position. Okay, most m MRU, most recent used position, which is I have assume consider the tail position, which is the most recent used position. You can do the head also, but you need to adjust accordingly. Okay, on insert, create a new entry and of the node and put into the hash map for a key, and also add to the tail in the DLL into tail, which is the most recent used one position, and update the uh, key to node mapping to get the in constant time. On removal, first check remove from the cache map. If it get the value, if it exists, it will give the value. Otherwise, it will give the null. If null, do nothing. If not null, means we have a value. So we have a key. So we just need to delete from that D double list. Okay. In evict, when we get the evict call, so we first need to check either our double list is empty or not. This will tell. If head pointer to the pointer to the tail, then policy is empty. Just raise exception. Otherwise, we'll get the, this is the LRU, least recently used position, which is the head pointer pointed to that node. So we need to, we get the key value, key, and unlink the head pointer and update the head pointer to the next head, and remove from the uh, hash map. Okay, and return the key need to delete from the main cache class. So this is the cache where I have make an entry, which is the so I will let you know here what why I have what the t represent the value, but for compilation error if we like defining this is v, this will give the compilation error. Why? Because it, while at a compile time it will ask you which v you are talking about, right? So for distinguishable, I am just defining another parameter which is t, but it represent t is equivalent to the v. Okay, t is equivalent to the v. And I am taking UTC time for expiry, which is expired at, that is taking a duration, and the duration I am taking for flexibility. You can pass the like expired in a millisecond, expired in a like minutes, expired in hour, a days. You can pass any form of the expiry time. I will calculate here according to the duration object. Okay, so as I have discussed, I make a variable of retrant lock, which is lock and cache map and policy capacity. Default duration days I will tell further what, why I am taking this one. This is the like around 2 years, but you can take like infinite one. Uh, this is represent like infinite expiry time. This is used when we are exposing a method for a put a uh, value for a key where we are not passing the expiry time, then we will mark it at infinite expiry time. Okay, so that the case we are using, and we have a constructor where we can pass the capacity and the policy, eviction policy, which eviction policy we want to use in that case. First, I will check the capacity should not be negative or zero, raise the exception, and create a cache map which will store the cache. As I have told you in earlier, cache is uh, responsible for telling us for a given key what the value and what is the TTL. It not responsible for ordering. Okay, so this is what I need to tell. So if you ever think HashMap internally resize itself at the 70% of its capacity, right? When HashMap full at 70% of its capacity, it resize itself automatically. So effective size is like if we divide the current capacity by 75, that is the effective side. Adding one for as for the threshold one. Okay. For lock and policy, just define it, and by default, if you pass if user pass the another eviction policy, we can pass it. Otherwise, if you just pass the capacity, by default it taking the LRU eviction policy. Put method, as I discussed first, it will take a lock, global lock for this operation, and I will just first get the node. If it null means entry doesn't exist, create a new entry and put into HashMap and insert into a policy so that it can add into tail of the doubly linked list. And also, if it exists, then mutate the value, update the value, and update the expiry time. But there is twist, right? Suppose I will let you know later. This is we can think about, like we can only update the expiry time if expiry time is not a default one, right? So that it it won't get extended expiry time of for a given key. So on update, this is the on access. We need to update on access, mean to delete. This is what it will do. It will delete from current position in from DLL and put to most recent use position, means tail position into DDL. Okay, so this is the, so in this we are updating two structure, right? HashMap and the double linked list. In last, I also need to check the HashMap if size is greater than capacity, means cache is full. Now we need to evict the least recently used one. So eviction policy tell us which key need to evict. Okay, then we will need to remove from the this cache and count the eviction, increase the eviction count. And in finally, after all these series of operation will done, finally we will unlock the release the lock. Okay. This is where I am talking about, where we are exposing the put method, where we can pass the put key and value. We are not passing the duration. We are assuming it, if it not passing, we are assuming it infinitely uh, long, means never expired until it deleted by the eviction policy. Okay, so in this case we are taking the default days, so that's why. So in this case we can check this here on update call. So we can check if uh, duration is the default duration day is the default day, we can just skip that part. Okay, forget. Similarly, forget, we are first checking, taking a global log, then we are first checking the, if key doesn't exist, just increment the miscount and return the null. And if it exists, we are doing the lazy cleanup. So for the expired one, first check the if it already expired, then we will need to remove from the cache map and the policy map, also policy, and also increment the miscount and return the null. For the valid one, we just need to access. We got the value. We need to access. Means we need to increment the hit count and move to the most recent position into DLL, right? And finally release the lock. So all these three operation is this series of operation in single atomic operation. Okay, so for similarly for remove, this is simpler one, like just we are first we are checking if it is removed from the cache cache map, and also remove from the eviction policy. This is the hit count public class, so you can get the hit count by taking a lock and a miscount and eviction count. So this is the implementation for, and whole implementation for the LRU cache, design LRU cache. I will provide the this implementation and the problem statement in the video description or in comment box. So for any query or any doubts, you can ask me in the comment box. I will pick one and I will clear that. Okay, so thank you.